webinar, An Introduction to Enterprise Software Performance Engineering. I'm Frank Days with Correlsense, and on behalf of the team at Collaborative Consulting and everyone here at Correlsense, we'd like to welcome you to our webinar. But before we get started, I wanted to take a moment and go through a few housekeeping items about today's webinar. Go next slide, please. The presentation today will last about 45 minutes. We understand we've stated we try to run it will last about an hour. We'd like to try to give you a few minutes left back at the bottom of the hour so you can have some time to get on to your next bit of activities for the day. During the presentation, do feel free to submit questions in the chat window. We'll be stopping periodically to answer any questions that people might have. Walter, our speaker, can do that. And finally, we'll be making both the slides and a recorded archive of the presentation available to people after the presentation via Correlsense.com and Collaborative Consulting's website. Well, without further ado, I'd like to hand the control over to Walter Kukits from Collaborative Consulting, who will be doing our presentation today.
Thanks, Frank. All right, we can get going here. So when we go through this, the goal today is to review the current challenges of being a performance engineer from a practitioner's perspective. What do we deal with? We're going to do an overview of what we've termed the 5 knowledge areas of performance engineering and introducing a body of knowledge. Then we want to discuss where performance can hit inside the software development lifecycle to help us build more scalable, more performance applications. We're going to go into application performance management, which is a key knowledge area on managing your systems. We're going to touch on the roles and the career path that a performance engineer might take. And finally, wrapping it all up and tying it together is a case study where we're just going to review how the 5 knowledge areas interact to prepare for a 10x event, and that might be your marketing team has decided to go really big and they're expecting volume to grow suddenly and dramatically. Okay. So some of the key challenges that we see today is the complex and highly distributed applications that we have. Different application teams may have different understanding of what a peaking factor is on those applications. Not all components of an application may agree what X is. The distributed infrastructure that spans many data centers, and your app could as well. For instance, brokerage systems are made of many, many subsystems. Each one may have a different value of X in terms of what the opening market day is. In terms of distributed teams, that's a challenge when you're in a test center of excellence, as your teams may be in different time zones. The performance execution team may be in one area, and your engineering and your scenario building team in another. The nature of our applications are constantly changing, forcing the performance team to keep up as mobile devices are being introduced. Third-party services with some cloud-based services, how do you manage and control those? So I think the performance team needs to keep up with the changes. And our ever-changing usage patterns. One of the big noticeable events are flash events and mobile anywhere, where people are no longer just locked into a Sunday night looking at your website, but with the iPad could be looking at it at any time during the day. So you have shifting patterns. Okay. Additionally, inside the enterprise, enterprises, large companies have release schedules, quarterly, monthly, as well as project-based. And that's forcing the performance team to react in either an ongoing performance team, performance tests running quarterly, also on demand. It needs to be satisfied through project basis. Projects may come and go, and a performance team may need to be brought up to support that. The user experience has never been more front and center in terms of influencing revenue on web companies. The website performance can directly impact your top line in terms of sales. If people have a poor experience, we all know they can move on. So I think this is also a boon for the performance team where typically it's been labeled as an indirect expense, indirect revenue, where you can actually say if you invest in the team and the processes and our tools, we can definitely impact revenue. From a budget perspective, keeping a lab in place for performance testing or to support production is expensive, and so you need to demonstrate that you're adding value by maintaining a high utilization of the lab. And then the team skills, where you build people with these teams, with these skills for performance engineering. How do you train them and what a career path might look? Oftentimes, performance engineers are part of the QA organization. They could be part of operations. They could be part of a shared services. Each group they're part of has a different skill set, and the performance skill set is a little unique. And oftentimes, some companies don't actually have a title called performance engineer. Okay. And part of this came out of looking around the marketplace at what are the standards out there, where is the confusion for what a performance engineer is. Across organizations, who decides on the definition? What are the responsibilities from a performance analyst to a performance tester? Typically, a performance tester is not a performance engineer, and the marketplace has trouble distinguishing the two. What's the difference between a performance engineer and a performance architect? Right? The engineer is more focused on the performance processes. The performance architect is more focused on the applications, the components. The performance architect might be very, very good at understanding the JVM. There's also confusion over, benchmarks, formal benchmarks, performance tests. A benchmark is usually a well-defined workload. A well-defined workload, and it can have a very formal process to give you an answer that you need to follow. And some benchmarks are done within the company. There could be a release, quarterly release benchmarks, as opposed to performance tests, which range greatly. They could be just a component of a. You could do performance testing for a particular component. Got some feedback. Where performance engineering body of knowledge. So now we got past that interruption. So many organizations separate performance testing from capacity planning. They separate production monitoring from the performance team, and architects are often separated or disconnected from the production team. So one of the things we're trying to do is get these teams closer together to share common knowledge across that. And I think great business value is delivered when all these components work together. When the application architect understands that they're impacting how their system that they've designed is actually being behaving in the wild, if you say, in production. And then the production team can give back feedback in terms of what the workload is. And so part of what we're trying to do is look at competencies, establishing a common language, and capturing common techniques that people can share within the business and across the business. Okay. So what we have here is our framework for what we're proposing as a body of knowledge for enterprise software performance engineering. Oh. We need to go back one slide. There we go. So the 5 knowledge areas that we have, they cover performance in the software development lifecycle and architecture. Of course, there's performance validation and testing, and there's capacity planning, APM, and of course, everybody's favorite, problem detection and resolution. And what supports those are really a set of competencies that align with one or more of those knowledge areas. And then certainly underneath the competencies, we have techniques on how we accomplish some of these things. And so here we have an enterprise performance team. There typically exists, and there must be a practice leader. And they're positioned as a shared service and a clearinghouse for performance information across the enterprise. And the team size and composition obviously changes quite a bit, but again, to facilitate communication from operations, architecture, being plugged into the business and what the business goals are, what their tolerance for risk is. And then they can also be part of the development team by collecting guidelines for performance. And so here's how that knowledge really gets transferred, where the performance team in the middle there, the application and development team on the lower left, the SDLC and the architecture, they build the system. They build the system according to goals and objectives for performance. Capacity planning works by sharing forecasts and trying to predict what the new workload will be. They try to figure out what is that going to do to the system when it's out there. And the application performance management team running and monitoring user experience provides key input to the capacity planning process, provides input into the performance and validation team, where if the workload changes in production, then the performance team must be aware that the workload changes and they should adjust accordingly. And so that's how it moves. And of course, we have the triage competency, if you will, because problems will happen, and understanding how to solve them quickly and what roles people play is a key part of it. So here we're going to go a little deeper into the knowledge areas. We're going to spend a little time on each one and what they're comprised of. So next. So here we have two typical SDLCs, the Agile and the Waterfall, or iterations. And what we want to do is inject performance tasks and activities into those methodologies. Depending on the risk profile of an application, it may require performance support during development, where there may be extreme requirements or penalties if a number of certain applications don't adhere to certain performance goals and objectives. In the define process, you need to understand the key transactions. How will the design support those goals? And that information needs to be communicated across the different components of the methodology. The Agile, I'm sure you are aware, is a little trickier. With Agile, we're doing systems, you're releasing systems with partial functionality. And so the workload is not complete. And so the challenge for performance is, what is the workload we should run? So for performance, you have to get comfortable with running partial workloads during an Agile release cycle and paralleling and being a little bit behind the actual release of each sprint. And so it's definitely a different approach to performance, where usually you'd prefer to start with a complete picture of the workload. In Agile, you piece together the workload. There's not a lot of options. And ultimately, can the system move from 10 transactions a second, and will it work at 100 transactions a second? And that's what your methodology and your life cycle with performance should do. Okay, so we're going to just look at each of these components of the life cycle with a couple of items to look for. Each project you can support with a risk scorecard, identifying the key transactions while you're in the define phase. Identify any workflow constraints. There may be a workflow for maybe entering a prescription that the pharmacist needs to support. There may be a workflow for placing an order in a brokerage firm. The business volume should be known. You should understand the peaking factors, and then of course, the business performance requirements. And there may be sub-second response time. There may be a plan for big events, and so that needs to get communicated downstream into the design team, which is where the architecture team starts to take effect. The technology, and we move into development. And the development team that's where the greatest impact on performance can happen. This is where those key functions that were defined actually get created, right? Does the development team know which key functions that they need to be aware of for performance? Are there unit tests that can be integrated into the development process to show early performance? Have they built for response time to be measured inside their objects or their components? Are there logging that should be implemented in order to help measure performance? And then the development team can also then impact the functional testing team. They can provide additional test cases to them. And the functional test team can be influenced by your performance test group, where there can be additional performance limited test cases, or the functional team can communicate and be that they have slower response time on some of the transactions already, and to educate the functional team that if they find something that's slow, it should be communicated. Oftentimes it gets just not even noted or pushed back, or later on when it's running a performance test, the functional team will say, oh yeah, that was slow for us as well. So it's really about getting early indicators and allowing it to happen and sharing that information. And one of the things to pass along and is used occasionally is called a performance budget with the development team, making them aware that, as you see in a complex environment, they're not the whole transaction. They're just a piece. In that transaction, you may only have 100 milliseconds to complete, or you might need 300 milliseconds to complete. And part of the architect's role is to communicate that downward on those key business transactions, letting people know that code does run everywhere. It's on the browser, it's on the mobile device, it's on the web server, of course the app and the database servers. And so each person, each developer along the way greatly influences the response time here for the overall system. This helps remind the developers that they have constraints. Okay. So the next phase, performance testing and validation. This is core performance testing within the enterprise. And one of the things we have to avoid is just we don't want to just simply start testing. There's a lot of prerequisites that need to be done before we test. Knowing why we're in the project, what the success criteria are, is huge. Oftentimes we've been involved late where the test was underway and nobody was quite sure what finished was or when they were done. So it's very important to know that going in to a performance test or a performance project. What do people consider done to be? And so these are kind of the prerequisites or entry criteria around this, where we need to understand the business goals in terms of non-functional requirements. We need to understand the workload, and this gets to your methodology. If you're waterfall or iterative, you should have a full workload and understand. If you're agile, you need to know and get comfortable with partial workloads as you're building through the agile sprints. The environment is where a lot of things can go wrong. If the environment for testing isn't set up or is woefully undersized, the environment will influence how much value you get out of a test and effort. And the application, is it in a stable state? It's not a perfect world, but it would be nice to have an application that is either completely through functional testing or mostly through functional testing, because you don't want to start performance testing and have to take multiple releases in on a 4-week project and restart every week. Configuration management and release management need to be able to deploy. Who is part of your core performance team, the people on the team, and then you need support team committing to you if you have DBAs or application people that need to potentially be on call while you're doing this. Then we're going to move into team value. One of the things that performance teams need to do is put a little marketing on. They need to continue to explain to the organization how they're adding value, what are they doing, and really raise the visibility level on how they've helped reduce response time out there. That's allowed more orders, more shopping carts to go through than previous. And the value for the team really increases as they learn more about the business in the application area. Excuse me. So they bring perspective in to setting up tests or to triage that, hey, here's how we do performance tests, and we understand your application. You know, the application architects and developers are not performance people in many cases, and they may not understand all the different types of performance tests that you need. Early involvement, big advocate of that for applications that are critical. And again, not every application needs performance testing, but for apps that do, getting involved early to understand how big the application is and some of the goals, understand the nature of the data to support the application. Test execution, understanding how to test accurately, how to collect information, how to provide meaningful results that your business can take action on, and provide a complete test results picture, not just response time, but beyond response time, what that is. And of course, another nod here to the environment. If the environment is a close approximation to the production, and what are the differences between the test environment and the production environment, that must be clearly known in order to answer some questions. What's different is very important. And then supporting that is the team reference model and what the performance team looks like. Okay, so this is a reference model where we typically have the core team on the left, the performance engineer leading, and then various levels of support team. You may have an application architect on loan when you're doing the test. You may need that level of support to understand how to troubleshoot, how to understand how to interpret it. Technology subject matter experts, if you're doing nothing but Java testing, you may need a Java SME inside the core team. You may need a Java subject expert on call. Data engineering, the same issue. If you need to understand the data of your applications that you're testing, you may need a core member to be part of your data team or an on-call data person. And for almost any project, and certainly mid-size and large, a key component is project planning and management for this. One of the key things that the performance team does is report on progress and compare testing to where they are today. Okay, now the performance team lives inside an enterprise. And so these are typically the support structures you see around your team. You know, infrastructure plays a big role. There may be a technology PMO to help you set your priorities, help you make decisions on what gets tested next if you're in a multi-release environment with 7 or 8 applications that go through a release cycle. Vendor management can be key. If you've got a problem with a database or a disk subsystem, you need to have a way to reach out to your vendors. Application support, so these are some of the things that are supported, and this support team needs to understand that, you know, you're on a shift that's, you know, 9 to 5, you're on a shift that's 11 to 7 p.m. or 7 p.m. to 11 a.m. What the team is working so you can line up the support organization. And finally, you do have to test eventually, so this is kind of our model for getting ready to test, getting the test to be run. You know, you must ensure you have a valid test with results you can rely on, because you don't want to be in the situation of running tests and not having collected all the right information. And so this flowchart moves basically from getting ready to run your test, initiating the test, watching the test, is it completed normally or abnormally, did you gather all the right results? You know, if you move from 0 to 1, 1 to 2, you know, going through creating the test report in the repository, from 2 back over to the left, there may be changes required for a retest. And so if you're retesting or rerunning a test, which is a special case, have you noted all the changes that were made and tracked them? Are you ready to rerun or implement the configuration change? And then can you retest? So that's a key component there in a test environment, logging and tracking changes to say what happened and what was different. Why did the test fail last time? Why did the test succeed this time? All right. Capacity planning. There are really 3 components for capacity planning. And they look at your current capacity, looking at today and being up to date on what's going on. There's determining the requirements of something new, if there's a change or a new application going on. And then forecasting workloads. So there's data capture, data analysis, and then forecasting. How is the workload going to change, and how is that going to change the use, the system utilization? And so capacity planning starts in workloads, and the workloads drive you through resource utilization. And a key thing that comes in for capacity planning is the dollar sign, where performance is focused on getting the test right, building systems right. The capacity is where the dollars come in to make sure that we haven't over-engineered something. You know, does it make sense on a per transaction basis or a per user basis? Are we, you know, did we spend the right money and we haven't over-engineered? And capacity organizations can be leading capacity teams. They may be heavily into forecasting and never want a system to run out of capacity, so they're always monitoring and measuring. Others might be lagging, where they look at it on a quarterly basis, and a couple of bumps along the way are okay, and then they readjust capacity on a less frequent basis. And capacity is watching the resources, how they're being utilized. In this complex system in front of you here, many components. The system has an overall capacity, which might be 10 transactions a second. Each individual component will have a different capacity rating. So if you look at the 10 transactions a second for the system, that gets translated down into the components. So the web server, from a resource perspective, might only be 20% utilized to handle 10 transactions. The application servers may be 50% utilized, and the database servers, 60% or more, or any component. So if you're going to, the business forecast calls for a doubling of business next year, and you're moving from 10 transactions a second to 20 transactions a second, which tiers do you have to reinforce? Which tiers may need more capacity? And that's where capacity planning comes in. And that's done through a combination of modeling and measuring. And so a workload model is created various ways. There are some very expensive and fancy tools for large organizations, and of course we all have the work spreadsheet that we can put in and use as well. And models need to constantly be validated. You can't just make a model once and that's it. The model needs to take the actual workload, which is coming from the monitoring tools. It could come from synthetic workload, which is a test, performance test. And as the system response times are measured, that gets fed back into your model. And what you need to do here is see that your prediction, is it matching your actual? So if on our 20 TPS example, we are predicting that the application tier, which was at 50% utilization in 10 TPS, is now going to be at 100% utilization or more, that should translate into a workload, and then we may need, obviously, to get a couple or more boxes in there. And so that's kind of a continuation. It doesn't, again, it doesn't stop with capacity planning. The next component, application performance management, a very dynamic marketplace today. There's a lot going on in terms of what people are doing with it. It's moved from focusing on resources to focusing on end-user experience and transaction tracking. Oftentimes, I'm sure we've experienced, a user might have a poor experience even though the system's not under stress. So this way, you can identify it from the user with some poor transactions and start digging into it. The Gartner, our friends at Cartner, have defined basically 5 components today of application performance monitoring. And it's basically the components, again, user experience from a browser or mobile device. They also need to create the runtime model. So the systems, these application performance monitoring tools get plugged in, and they'll actually discover what the underlying infrastructure is, and in some cases have discovered a component people weren't quite aware was there. Then you need the flexibility to profile your own transactions besides just user response time, maybe some subcomponents in there, and then allow for deep dive metrics across all the tiers that make up the transaction as it flows through the system, and storing everything in an application performance management database for analysis. And so here's the dashboard, if you will, starting with the APM tool. It is focused on an online trading application and shows you, simply red, yellow, green, how your transactions are doing. And from here, you can get to the next level is you want to do some diagnosis on the application. And they're broken into 2 key components to support our mobile world. From the data center out, you can look at and measure and isolate the user experience in the response time within the browser or within the mobile device. And they can measure rendering time. And so as you dig into it, you can see where time is being spent by the user, monitoring network latency. And as applications are being plugged more into the cloud, that network latency starts to become a big key factor to watch as the applications get spread further and further out. Below that, we can really dig into where our time is being spent on the transaction. So as you're doing your shopping cart, purchase, or you're looking at inventory, or you're confirming an order, and it's slow, you can look and measure where the hops are taking, where the time is taking, which is very powerful for getting to root cause quickly. In the old days, or maybe even today, we all have been on those phone calls where each person responsible for those subsystems is trying to figure out where slow is, right? Diagnosing slow without the right tools can be a challenge. Also want to mention that within this, sharing tools across the environments, so this is geared towards a production environment. If you move this tool into the performance testing environment, it becomes a very powerful story because now you're testing and monitoring in the same tool that production is. So getting apples to apples using the same tools can be very helpful, especially if your performance team needs to support a production outage and you need to recreate that inside a performance test lab. PDR, problem detection and resolution, very important across our knowledge areas. And generally, in this case, it's under duress. We're looking for a problem that just popped up or came to us suddenly. A solution must be found quickly. So this skill set and this knowledge area crosses pre-production environments and production environments. Pre-production could be a pilot in the performance testing lab. Also critical is use for a proof of concepts where the business is evaluating a technology and they need to test it and many times POCs experience problems along the way. So having a well-documented process for finding them is going to accelerate that curve. And problems will happen, and you need to be ready for them and move on quickly. You know, the problems can manifest themselves in a number of ways. Typically, it's the end user. It could be an overnight batch process is giving you a problem. It's spilling out the batch window. You might not be able to calculate the net asset value or meet a regulatory requirement. And many times, problems occur. They're self-inflicted. So any changes typically can bring unintended consequences. And that's where they come into play. And so this slide is just to kind of bucket them, if you will, when they come up and to be ready for them. And so this can feed back into the problem detection resolution can be provide great information back into the architecture and development lifecycle to not do things again. So again, sharing that information that said you made a coding change that now manifested a problem in production, to make sure that information gets back and is shared and is captured. Consolidation of applications and servers, that can always provide a difficult challenge as people are combining workloads onto one physical server, and that physical server is hosting many virtual services. And they can get in the way of each other. The workloads can interfere with each other. And so having an aggressive APM solution for those applications to get early warning is critical. So the next part of our body of knowledge is the underlying competencies that support these knowledge areas. And so these competencies really cut across most of the knowledge areas. You know, you need to be a project management regardless. You need to have good analytical thinking and problem-solving skills, which encompasses how you make decisions. Are you a creative thinker? Learning and adjusting. Many times we learn new things and need to come up with new solutions. Systems thinking is critical, that people understand, you know, systems of systems, not just a response time for a particular web transaction. Having business knowledge is very important. Being aware of the organization, some insight into how they actually allocate budget is very important for your organization. We have our own individual behavioral characteristics. For instance, how organized are we? How well do we communicate with others? Test data management. I can't say enough about test data management. And we went back and forth. I contacted my friend who's been helpful here. We went back and forth on test data management, and it's a competency that goes across the knowledge areas. It's pretty much used everywhere, and greatly influences the success or failure of the project. Okay. In addition to those competencies, we have technical competencies. This gets to tooling and really where performance hits the road here. Performance in one aspect becomes physical here. How you build your database, how you build your code, understanding static code analysis and diagnostics for code profiling tools, understanding how to get CPU metrics and resource utilization quickly. Understanding the end-to-end performance tools. Statistics is very important for test analysis, and understanding variance for key transactions, the distribution of those transactions as well. And there's queuing and modeling tools for some of the bigger systems. Very important that these are here. And as people participate in performance engineering, they kind of gravitate towards one or the other over time. Next, to support the competencies are really techniques. And there are techniques we've all come across, and there are techniques that we need to share within the business, within our enterprise. Something simple as brainstorming. How do we solve a problem? How do we, you know, in the SDLC architect a different solution. How do we move from maybe from polling to an event-driven software? How do we do creating a workload model? That should be a technique that's shared. Static code analysis, logging and instrumentation, very important that applications are properly instrumented, and they should be written knowing that they may have a production problem. So how can we get information out of those quickly and let the application help us figure out what's going on here? Another key technique is facilitation. Many times performance is not done in a vacuum. Many people and many disciplines are involved, so understanding how to do facilitation, very important. And then I thought we'd just show a few samples of roles within the performance engineering organization. Large teams and projects, it's mandatory in my mind that they get a technical project manager. The performance team should do what they're good at, and the project manager should help them communicate that and track it. The architect, you have senior levels of performance engineer and senior levels of test automation engineer. Test automation, they're the people who are writing the test scripts and the tools, whether it's to drive load on a web server, drive load on an application server, different tools, and they're the ones who turn the test strategy and plan and scenarios into the actual execution. Data engineer for bigger systems is very important that the team understands the data, and of course capacity planners, and even modelers, how they're modeling systems. And part of the foundation is I thought I'd take a path at creating a framework for the performance engineer career. And I'd like to look at it as a pyramid. You want to grow your technical skills and capabilities on the bottom dimension to increase the size of your pyramid, and then upwards you want to grow your leadership and communication. And this is, again, just a sample. I'm not saying that performance engineer is the top of the pyramid. Certainly this pyramid could be bigger. But these are the types of things that as people start off, they might start off as a very good Java programmer who learned how to troubleshoot, moved his way up to technical architecture, and then started participating in performance tests, mastered testing, and moved up to a performance engineer, which still has one or two core technical competencies. They can communicate well. They understand how to build workload models, and a more senior person. And this is kind of a foundation to help people grow their skills and maybe even in some instance communicate to their HR department if such roles don't really exist. And so that's kind of a tour of our performance engineering knowledge areas and our techniques and our competencies. And so what I thought I'd wrap up with is a short case study that ties those components and those knowledge areas together. Under my favorite case study, the flash marketing event, and that is a sudden spike in load on your system driven by something the business or marketing team has put together. So let's introduce a new product to our 500,000 registered customers. There's an email sent out to 500,000 people with a link. Just simply click here on perhaps 11 a.m. Monday. They support that by running multiple TV ads encouraging people to register. So perhaps they pick up another 100,000 new registrations. But thankfully, they haven't changed much. There's no new functionality, and now we're up to about 600,000 users. And so now the business is forecasting a 10x increase during the event in terms of sales. And so now the job of the team, the performance team, is to translate that into system workload and system utilization. Answer the questions: are we prepared? Do we need more servers? And by the way, the current system really wasn't designed with 10x overnight in mind. It was more of a gradual approach to monitor and put things in place to scale. And so the process to work with the knowledge areas together, it really starts on the left there with the capacity planners forecasting the workload. How big could it be? What is the profile that might be executed? The capacity team will then shift to the right and say, okay, let's get all the current information. How is the system being used today? We need to measure it. We need to get the current workload and resource utilization. And so we rely on the APM tools to support that. The performance database is part of it. Coming out of that, it may be determined that this warrants a round of performance tests in order to validate it, because there's not a confidence in the business or the IT team that the system will gracefully handle 10 times the load. So a set of performance tests are set up and designed in order to do that. And on the far right, we have the system software development lifecycle with the architects and team who are going to help tune this application and get it up to 10 times or perhaps more. And then during that time, we'll need the problem detection and resolution, because oftentimes moving from where we are today to a 10x volume, things break along the way. There may be problems in the database in terms of concurrency. There may be threading issues. There may be other looming issues that are waiting for us there. So this is kind of an overall picture of how to answer that, and then to communicate to your team that says, here's the components that we're going to use to satisfy that business request to get us to 10x. And here's a high view of the workload model. The performance team puts together, who are logging in. They'll search, they'll view a product detail for 100% of the time. 50% of the time, they're going to add it to the shopping cart and confirm the purchase. So that gets to the conversion rate on your website. So for this new marketing event, has the marketing team changed the conversion rate? If your current conversion rate is 10%, are they expecting something vastly different than that, which is going to exercise the system differently than it is today? So it's very important to know that. The team needs to look at the current capacity of the system, the average workload, the current peak workload, and the simple plot here of response time to utilization of today's system overlaid with your service level. If your profile step of search product or view detail is 2 seconds, under what load do you violate the 2-second rule? And how far away from 10x is that violation as well? So this is about collecting system information below this, because this looks at the system. You need to look at the components below that in terms of CPU metrics and database utilization. And then for the performance test, this involves test planning and results review. Cover a stress testing approach for the application. Most applications break well before a 10x level, but during the testing process, again, the development team will be involved in making changes and asking you to retest for this. So the results reporting, gathering the detailed metrics on the utilization for the test workloads critical. Helping understand how to scale the application can come from here as well. And then we design and build the tests and really iterate through the testing cycle. And so that's a quick overview of kind of putting it all together with our application performance, enterprise software performance framework. And that ends us. Thank you all very much for attending.
Great, Walter. This is Frank Days. I'd like to thank you for joining us today. And if you have any questions, feel free to visit either our websites or email us at info@correlsense.com.
Fantastic.